Welcome, everybody. The first thing I'll say is that the assignment is not tomorrow. The assignment is Tuesday. And I moved it so that we could, today we're just really covering two big ideas, essentially. And so there wouldn't be enough content to put onto it. After we finish today and tomorrow's class, there'll be kind of like four big ideas, and that's really the whole unit, because we're going to skip so much, which we're going to mention. But yeah, the assignment will be on Tuesday, and it'll cover everything that we did up until that point, Sunday and Monday's content. So that would be the first thing I want to mention. The second thing would be this unit had to be cut down in length because we lost Tuesday, Wednesday, Thursday. Of course, you know this about a week and a half ago. That's the equivalent of 6 classes in the semester, 3 classes in Ramadan, so it's a ton of content. We had to cut something. So we cut the first 14 pages. So we're going to jump straight to page 15. And it looks like this. This is not the version I want to see. It's page 15. What is going on here? Oh, I see. Sorry. Going to skip all this. Skip. Most of it's review of 1700 anyway. There we go. Okay. So the reason we're skipping that content is because in Math 1700, you already covered the basics of trigonometry. There's no real reason to go through that. But the stuff we're doing today, you didn't quite cover in the previous course. So nothing that we skipped isn't something that you've either seen before, or it's something that will come back in a later course and it'll be retaught anyway, so nothing to worry about. We're going to start with the graphs of, it says 6 trigonometric functions, and they're the 6 most common trig functions, not including sine and cosine. Of course, sine and cosine are like our parent functions. Sine and cosine are true, fundamental functions that we've dealt with already. Tan, cosecant, secant, and cotan are all built from those functions. So let me just quickly recap that, because that's the fundamentals of what we're going to do here today. So the first things first, we have 2 functions, sine and cosine. We also have the function tan, but tan is really just sine over cosine. So it's the sine function divided by the cosine function. And that has interesting properties, actually, because at some points cosine is going to be 0, so it's going to cause us to divide by 0. But we'll deal with that in a second. Of course, we have cosine. Actually, all of these are here, so I don't need to write them out again. I'm not sure why I am. We have tan, cosecant, hello there, cosecant, secant, and cotan. And we're going to talk about what the functions are. Are you writing something that I should be concerned with here? What's going on? Who's writing on this? Are you okay? You feeling all right? Everything going according to plan over there? Let's get right into it. The whole point of this introduction is just to recognize what the graphs would look like. And the easiest way to do this is to put it on Desmos. But I'm going to give you tools to figure out what the graphs are without using Desmos. Okay, just giving you some interest, just giving you some understanding of how the graphs work without using the calculator. And first things first, it says, why are there asymptotes? What we saw in the previous unit what an asymptote is. An asymptote is a line that the graph tries to get to, but never quite touches. And actually, now that it's on my mind, the first thing I'll say is that a lot of what I'm going to cover for the rest of the year, really, is going to be things that Mr. Tom also covers in his videos. And normally I like Mr. Tom's videos to serve as kind of an introduction, and I'll do a little bit and then kind of do new stuff. But the way that these other topics go is it's very difficult to do the examples or the practice without doing the introduction first, because it's so important. It's difficult to catch up unless you have the introduction. So I guess what I'm trying to say is Mr. Tom's videos are still important, but I'm going to be covering a lot of the same stuff. So for some of you, that's a good thing, because if you come to class, most of what you'll need to know I'll cover in class. And Mr. Tom's videos can be kind of a backup because it'll just be easier that way, as far as I can see. So anyway, the reason I thought about that is Tom already went through all this, but I'm going to go through it again my way, just so that everyone's perfectly clear, okay? I don't mean to retread. I just want to make it clear. Okay, so back to the idea. Why are there asymptotes? Well, asymptotes are these dotted lines here. You can see that there are these lines that the function, this blue line, which represents the tan function, never touch. And we covered that in Unit 3. Let's just quickly talk about why there are these asymptotes. And you might already know why, especially if you watch the video, you would know why. It comes from this. We get asymptotes, vertical asymptotes, when there is division by 0. We will have asymptotes when cosine of x equals 0. So whatever values you put into this, if you put in a certain x value that makes cosine of that x equal to 0, then it's going to be division by 0 for tan. It's going to explode. And we can actually see from the graph what these values are going to be. So when, which values does this asymptote have? We have pi over 2 is a value that makes it divide by 0. 3 pi over 2 would be a value that would make it divide by 0, and so on. So let's just take a look at this. I'm going to show it's any time that the x value is pi over 2 or pi over 2 with a pi added. So let me just make sure you know what that means. Anytime it's at pi over 2, there's going to be an asymptote, plus or minus any value of pi. So if we add pi to that, if we add 2 pi to that, if we add 3 pi to that. So let me bring up the calculator so you can see what I mean. Oh, first things first, when I'm speaking about the calculator, you need to be in radians for this unit because all of our calculations will be dealing with radians. So in case you don't know how, go Shift Mode, which goes into Setup. If you don't have the Casio, you'll have to figure out how to do this on your own calculator, but it's basically the same for all calculators. Just find the Setup or the Mode function and look for radians and make sure that you type 4 in this case, but make sure that you put it in radians mode. For the calculator, the Casio calculator, you'll see a little R here on the top, and it tells you that you're in the right mode. The reason that's important, just look at this. Cosine of pi over 2. Cosine of pi over 2 should give us 0. I know this because I just know these functions, but you can do it just by experimenting. Should give 0. If you use your calculator right now, which you should try, if you type in cosine of pi over 2 and you don't get 0, you're not in the right mode. If you're in radians, it will definitely give 0. If you're in degrees, let me just show you. If I was in degree mode, right now I'm in degree mode, and I calculate this, you're going to get something like this, 0.99962. That is not 0. It's almost 1. So there's something wrong here. If you're in radians, you'll get nice, clean answers. If you're in degrees, you'll get crazy answers. And you know you had to be in radians because pi is our clue. It tells us that we need to be in radian mode. Okay. So make sure you're in radian mode is my point. Now, let me show you this. I said that it's pi plus or minus n pi. That means plus or minus 1 pi, 2 pi, 3 pi. So let me just show you. If I add a single pi to this, so add 1 pi, it should still give 0. If I add 2 pi, it should still give 0. 3 pi, 4 pi, 5 pi, a million pi, it doesn't matter. And even if it's negative, as long as that number in front of pi is a constant, so minus 2 pi, for example, it should still give 0. And I am getting to my point. There's a good point. Let me show you. What this means is that we're going to have asymptotes at the values of, let's say, pi over 2, or it would be 3 pi over 2, or 5 pi over 2, and so on. Where do those values come from? Well, pi over 2 plus 0, pi over 2 plus pi, You know, pi over 2 plus pi is the same as pi over 2 plus 2 pi over 2, just common denominator. That gives 3 pi over 2. So that's why this works out the way that it does. You don't need to do that every time. I'm just showing you some basics. The important thing is you notice that my rule matches where the asymptotes are for this function. You won't have to draw this yourself. You'll just be given the graph as, let's say, a multiple choice question or a fill in the blanks question, short answer question. You just have to tell me which graph is which, right? So that's our basics. When it comes to tan, that's where our asymptotes will be divided by 0. Let me move on so you'll see the big picture first. I'm going to give you a shortcut at the end. Cotan. Well, cotan is basically the same as tan. Look at the shape, right? The shape for tan is like this. It's like a line that goes up and repeats. Cotan is the same story, but it's a line that comes down like this. And let's see, cotan, what's our function? Well, it's not sine over cosine. It's cosine over sine. If you don't remember that, make sure you look it up in the table. Try to memorize it, though. It's more helpful. And then what do I need to do? Where will I have asymptotes for this function? Does anyone know when sine is 0? So when sine x equals 0, what values of x will give that? You can experiment it on your calculator. You can try putting in 0, put in pi over 2, see what it gives. Or just look at the graph, right? Where are these asymptotes? Which values are we talking about here? Well, I can see some. I can see 0. I can see there's an asymptote at pi. See there's an asymptote at 2 pi. I can see that this is 2 pi over here. There's an asymptote at negative pi. There's an asymptote at negative 2 pi. There's an asymptote at negative 3 pi. So all of these are okay. What we'll notice is that it's all whole numbers of pi. Or in math terms, plus or minus any n times pi. N is just a natural number, 1, 2, 3, 4, 5, any constant, any integer constant. So any multiple of pi, 1, 2, 3, 4, 5, 6, 7, and so on. So just try it yourself. You know, take your Casio or any calculator, just type sine, and then type pi with any number in front of it. So 3 pi. What does it give you? I got 0. You should be able to put in 4 pi, 10 pi, 15 pi. Take any number, 1,000,000 pi, and put it in. Sine of 7 pi. You should get 0. Any whole number of pi will give you 0 for sine. So that's why we see the pattern that we do. You'll notice that every whole number of pi, you get these asymptotes. Negative pi, negative 2 pi, negative 3 pi. Very simple. That's a simple rule. I'll give you an even more simple rule soon. Okay. For some of you, you're like, okay, yeah, I see that. You're getting the vertical lines when the sine or cosine is 0 on bottom. And others of you are just like, what's happening? What's happening? It's okay. There's a mix. Some people hate trig, some people love it. It's okay. You're allowed to love or hate it. I want to show you the other two, and then I'll summarize it. So secant. What's secant? Secant is 1 over what? Can you remember it? It's either 1 over sine or 1 over cosine. Which one is it? Is it 1 over sine or 1 over cosine? Students mix these up all the time.
Cosine.
Cosine, sir.
Hmm?
Cosine.
Cosine. Yes. The way I remember this, because I have silly ways to remember pretty much everything, because I don't have a great memory, so I always had ways to remember it. Secant, we know that secant and cosecant are 1 over something. it's going to be 1 over c. And the way I remember it is it never matches the same letter. So secant doesn't go with sine, because then you'd have s twice. So secant must go with cosine. Same thing with cosecant. Cosecant doesn't go with cosine, because then you'd have two c's together, and it doesn't work like that. There's got to be a little change. So that's one way I remembered this, is secant goes with cosine, cosecant goes with sine, because this s turns into a c. Or just remember it, or use a formula sheet. So cosine. When is cosine 0? We already talked about this. So there's asymptotes when cosine is 0, cosine of x is 0. We already know what this is, or at least I already know what this is. We already talked about it. We know that cosine is 0 when we have pi over 2 or any constant multiple of pi over 2 added to it. So pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. Okay, and we can see that here. It's an asymptote at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2, multiples. And secant, they look like kind of like, I don't know, cups. It doesn't have that linear shape, it has a cup shape. Cosecant is the exact same shape. The only difference is where the asymptotes are. The asymptotes are kind of like this. And let's just finish our story here. Secant, or cosecant. Cosecant is 1 over something, because it's secant, just cosecant. It's 1 over sine. If we have 1 over sine, we have asymptotes. Asymptotes when sine of x equals 0. Remember, when we divide by 0, the function explodes. It goes to infinity, because we're not allowed to actually divide by 0. We're never actually allowed to touch that value. So the function kind of doesn't know what to do there. It just explodes. So when is sine of x equal to 0? I already told you this. It's when we have any plus or minus n pi. So any constant multiple of pi. 1 pi, 2 pi, 3 pi, 10 pi, negative 10 pi, negative 5 pi. Any number in front of pi that's a constant integer. Okay, so those are our 4 types. You could easily type them all into Desmos and figure out which one's which. Wouldn't be too hard. I want to give you just a shorthand way of remembering it. Let me write a little table for you first, and then I'll give you an even sillier way to remember this. So we have 4 functions, yeah? Let's just make a list of our 4 functions. What are our 4 functions? Well, we have tan, we have secant, we have cotan, and we have cosecant. We'll split them into 2 groups like this. Let's consider their asymptotes. And hopefully you've noticed the pattern in the asymptotes. The asymptotes are just the vertical lines, remember, vertical asymptotes that the function never touches. Tan and secant both have the same types of asymptotes. What are they? If you look earlier in the notes that we have, what are the asymptotes for tan and secant? They both have cosine on bottom. Anybody? Am I boring you to death? It's just Sunday back from break, and I've already just made you all really sad, haven't I? Just math again. Like I never left. Okay, the asymptotes for tan and secant are pi over 2 plus or minus n pi. Okay, I'll give you that one for free. The asymptotes of cotan and cosecant are easy. Just any constant multiple of pi. I hope you're still following, okay? Because there's a little trick I want to give you. These, I'll say they don't, if you're looking at the graph, the asymptotes don't go through the center. They don't go through x equals 0. These, they do go through x equals 0. But there's an easier way. Let me give you a little trick here. If you have a function that starts with c, cotan, cosecant, they both start with c. their asymptotes will be easier to figure out. By easier, I mean they go straight through 0. You know that it's just 0 or pi or 2 pi, really easy values. Let's just confirm that. You know, you have a C here, you have easy asymptotes. This one is not C, so it doesn't have as easy asymptotes. They're trickier. So let's look up here. Cotan starts with a C. It has easy asymptotes. Let me draw that better. They go straight through the center. They go right over to pi. It's nice and predictable. Tan doesn't start with C, so the asymptote doesn't go through the center. It's a little trickier. So what am I trying to make? What kind of point am I trying to make here? I'm trying to give you a little bit of a silly way to remember this. And the way I remember this is functions, let's start with C. Have easy asymptotes. And easy asymptotes, it's like EC asymptotes. Come on. Is that good? Isn't that the best? Isn't that the best thing you've heard all day? Easy starts with C is easy. Easy starts at 0, nice and easy. Pi, 2 pi. Isn't that nice? I mean, tell me that that doesn't help. So we look at this function. I'm like, what function is this? And they're like, hey, look how easy those asymptotes are. 0, pi, 2 pi. How easy. It must be a C function. What function is it? There's only 2 C functions. It's either cosecant or it's cotan. Cotan looks like a line. Secant stuff looks like cups. It's got to be cosecant. So you don't really need to worry about all these extra pieces. You can kind of figure it out just by the EC method. Come on. I know if this was a class right now, you'd all be like, yes, yes, Mr. Scott, Mr. Scott. You know, that's what I imagine the class would be like. I assume that that's what it would be like anyways in my brain. Okay, so hopefully that helps. For example, let's just say I was to look at an old test. Like maybe this is the old test. You know, I'm even looking at it. Fall 2019, a version of the test that I have. So let me just quickly, I'll just snip this, put it in our notebook. So let's just say we had a quick question. You know, if I gave you a quiz or an assignment, hint, hint, maybe I would ask a question that involved this. So I would ask this question and say, which trig function is shown in the graph below? And you would look at it, and you could either you could tell me one of 4 functions, yeah? You could tell me if it's either tan of x, or it could be secant of x, or it could be cotan of x, or cosecant of x. Which one is it? You know, you don't need to think too hard. First things first, are the asymptotes easy? Easy. So first things first, I would say they are not easy, so they don't start with a C. And it's either tan or secant. I'm seeing a lot of tan in the chat. Yeah, because it has a line shape, right? It kind of goes up. It's almost cubic. It goes up. It doesn't make a cup shape. So yeah, definitely tan, because it looks like this. Not like this, because secant looks like that, you know? So you don't need to know all the extra information. Of course, you should know it. You know, make sure you know those little pieces that I showed you. But if I'm just asking you to tell me what graph it is, there's easier ways than writing out all the stuff, you know? The asymptotes are not starting at 0, so it's got to be tan or secant. And it looks like a line, so it's tan. All right. So multiple ways to remember this. I'm just trying to give you different tools to put in your toolbox. And when you need them, you take them out and realize you're missing some of the pieces. And you're like, ah, I'm sure I had this screwdriver. Anyway, I'm thinking a lot about my house because we're moving. But, you know, remember whatever way you need. Okay, I think that's it for that topic. We're going to move on to the next topic. That's all there is to it. Actually, the only thing left I'll show you is, let's just say you didn't catch what I said. You didn't understand it. You're confused by the whole easy thing. You're like, why is everyone clapping and so excited about this when I don't even understand it? If you don't know which function's which, if I ask you on a test, what's the function, just use Desmos, you know, if you need to. I'd prefer you just know it. But, you know, tan, what was another one? Cosecant, could also be secant, could also be cotan. And just turn them on and off until it matches what you're asked for. So let's see, we have this function again. We see that it has, you know, a line, there's no asymptote through the center. So I look at this and I'm like, hey, yeah, that matches. It has this form and it goes right through the middle. Yeah, that looks good. And so it's tan. So you would match it in this way. If it was a different function, maybe you would use something different, you know? You would just match it as you see fit. There's only 4 of them. You shouldn't have any trouble. Okay, so 2 methods. Use my trick method, which will help you in future courses, which you don't need to use a graphing calculator for, or you can use a graphing calculator and work backwards. Whichever works for you. I'm not going to tell you how to do it. I'm just going to give you options. Okay, any questions on that before I move on to the next topic, the next big topic of the day? All good. They're quiet today. Maybe some of you haven't slept.
No, we don't have question.
All good, okay. So again, if you came late, you might be like wondering, why am I on page 16? Well, it's because I skipped pages 2 to 14. I said that on D2L and everything, but sometimes people miss it. Another important information piece is the assignment's not tomorrow, the assignment's Tuesday. Yeah. I'm going to try to repeat that so that you remember. Just get it in your head. The assignment's Tuesday. Okay, so one other thing I'll say in general is that I think, from my point of view, you've kind of finished the hardest parts of this course. I think the rest of the concepts, except for a little bit of Unit 5, most of the course is going to be pretty easy for you. I think. It's going to be slightly easier than it was. So for those of you that are worried about what's coming up, just know that the rest of the course is not too bad. There's, of course, lots of things to still learn, but each piece is not that complicated. So as long as you keep up, come to class, keep up with the videos, do the practice problems, all the regular stuff, you'll be okay. And honestly, I think some of it is actually even interesting, which is a nice bonus if you're not in love with math. Believe it or not, I'm not in love with math. I enjoy math, but I don't like read books on my spare time about math or something like that. Okay, let's get to it. What are we looking at? The graphs of y equals sine and y equals cosine. All right, the important quantities. So it says we have 2 formulas here. This is our like general formula for sine and cosine. You remember we had like general standard forms for our other types of graphs, like ellipses, parabolas, things like that. These are our standard forms for sine and cosine. They're very simple. You might have even seen them before in your engineering courses. And there's 3 pieces that you need to be aware of. One is the amplitude, which is related to the A value. So you'll notice there's an A in here. Another one is the period, which is not the B value, but it's related to the B value. And finally, we have our displacement, also called phase shift, also called phase angle, also called horizontal shift, also called horizontal translation. There's lots of words for it. It's related to the C value. and we can mix and match them, okay? So this is our big idea. We have our general equations, and they have three pieces that change the function, A, B, and C. So before I talk about a lot of this stuff, let me show you it on Desmos, because I think it'll help you understand it a lot better. How do A, B, and C affect things? So this is a graph of a sine curve. I'm assuming you've seen a sine curve before. I'm pretty sure you've even seen them in this course. If you're not familiar with them, well, this is what they look like, okay? So in this case, just follow me clearly, or follow me closely here. In this particular example, you'll see I have my standard form, and I have my A, B, and C values. A is 1, B is 1, and C is 0. So really what that means is I have y equals sine x, because there's a 1 in front, whatever. This is just our basic sine x curve, okay? Now, if I mess with it, if I start fooling around with the values, things will change. So A, what does A do? Well, if I change A, let me make A bigger and see what happens. So by A, I'm talking about, I'm talking about this A. What if I make it bigger? What if I made it 2? Well, what would happen? This would happen. What does that mean? It means that it originally looked like, this, more or less. That's my original function. Actually, let me save some headache here. I'll just type the original function here in green. Oops. Just bear with me, I want to make this better. Okay, that's our original function, the green function. What happened when I changed A? It made it bigger. It changed the amplitude. If I make it up to 3, it stretches it up to 3. So A is very simple. It just stretches the function. It makes it a new amplitude or a new maximum minimum point. 3 away from the center line, or 3 down from the center line, 3 up from the center line. So let's put that back to 1. And let's see what would happen. Come on, go to 1. Let's see what would happen if I messed with B. Well, B, you can see, well, hopefully you can see, B is touching the X value. So if I mess with it, it should change the X value somehow. Let's see what happens. If I make it big, whoa, it goes from being stretched out to being compressed. We're like pushing it in like a spring. So you can imagine the sine curve being almost like a spring. We're compressing it down, or squishing it, or squatting it, compressing it. We're making it smaller. So the bigger the B value, the more compressed it is. And really, really big B values compresses it down. Another way of looking at this, let me just explore. The original period of the function, which means the original, from where it starts to where it repeats, you'll notice hopefully this is one cycle. This is one like full periodic curve, one full sine curve before it repeats. That distance here is 2 pi. Some of you might know what I'm talking about. Others might, this might be a review. This distance is 2 pi. That's the original period. That's the original amount of time it takes to get from the first cycle to the second cycle. Again, this is something that happens over and over. It's just something going up and down and 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 up and down forever. It originally takes 2 pi. If I mess with B, it changes the period. It makes it way smaller. So bigger B, smaller period. Smaller B makes massive periods. Okay, it increases the length of the cycle. So that's good for that. Let me erase some of this. Period is, so the period is like frequency, but it is not frequency. They are related. Frequency is how many times per second it happens. Period is how many seconds it takes to do its thing. So for example, something with a period of 2 pi, 2 times pi is about 6. It means it takes about 6 seconds to happen. The frequency of that would be 1/6. You just divide it by 1 or divide it into 1. But yeah, frequency and period are related. You might already know that from physics. Smaller period means higher frequency. Let's mess with C. What do you think C is going to do? It's called displacement. What do you think that means? What was a time where we had a shift before? Anyone have any ideas?
It can move it right to the left, like this.
Right, left and right, yeah, exactly. It won't move it up and down because it's actually kind of, you can see it's in with the X value. So it's going to move it left and right, just like we expected before. Oops. So we move it left and right. It just shifts it. It's called displacement when we deal with sine curves or cosine. But really it's horizontal shift, like horizontal translation like we saw in the last unit. So we'll notice if it's at 0, nothing happens. If it's big, for example, I made it 2, it'll shift it left by 2. So that's the effect that it has. So in summary, if I mess with the A value, it makes it taller. It increases what's called the amplitude, the height, or the stretch. If I change B, it messes with the size of it. It's a horizontal stretch instead of a vertical stretch. And then if I mess with C, it goes back and forth. I move it left and right. So stretch up and down, stretch left and right, move it left and right. That's all we're going to be dealing with. So I hope that didn't blow your mind too much. I hope it helped. You're not going to have to mess with Desmos too much. I just want you to get the basics, okay? So the amplitude, another way of saying it is it's kind of like vertical stretch. Period is, well, it's actually B. A is the vertical stretch, B is the horizontal stretch, and C is displacement, shift left and right. We'll deal with that in a second. I think you'll find that the math part of this is a lot easier actually to do than the understanding part. So let me reiterate a few things. It says graphs of trig functions are plotted on the rectangular coordinate system, so just x and y. The angle is x, but it's measured in radians. So once again, if your calculator's not in radians, you're gonna have a lot of trouble at some point. So make sure you change it to radians. I'm sure you have had courses before that deal with radians. So make sure you have that. Amplitude, it says a lot, but it's actually only saying very little. Amplitude A, it's saying it's the vertical distance from a minimum to a maximum. It says 1/2 of the vertical distance, but really what it means is if we had a curve like this, half the distance, that's our amplitude. You could deal with it both ways. I think you've dealt with waves before. If not, this is all we're talking about. Period. Period is how long it takes to get from one point to another point on the same curve, the exact same point, the length of one cycle. Generally speaking, that means we'll pick something like peaks. So for example, for a sine curve, if this is repeating over and over, that would be the distance from, let's say, from here to here. That would be our period. You'll notice Muhammad said earlier it's like frequency, or it is frequency. It's not frequency, it's how long it takes to get from one point to another, or one to repeat. So you'll notice that these are both period. You just choose any old point on the graph and find the same point again later after a full cycle. And then finally, displacement, also known as phase shift. It's the shift right or left. And one note that might come up, it's determined from the movement of the original y-intercept. So let me just bring up a point here. I'll draw a little picture. Let's just say we had the original function sine. This would continue on in both directions. If we were to shift this a little bit over, maybe shift it to the left, it'll be the same as taking this intercept and shifting it over here, making it over there, and then we'd remake this function. it moves that way. It's not the best drawing I've ever made, but all it means is that you shift it sideways. And we can just look at where the y-intercept used to be and make our point from there. So you look at this graph here. For example, in the original function, the y-intercept was here. Now the y-intercept is over here, and you could use that to figure out what it's trying to ask you. But you'll see that in many cases, it's actually easier than it looks. So let me actually go into the examples. Any lingering questions? I haven't actually had you do much yet. We'll get there in a second. But is there any questions on amplitude, period, or displacement? Okay. Of course, interrupt me anytime. I do want to mention that, these are use this as a reference. Really, it's your formulas. So, you can take a picture of it, you could write it down on a little note on the side of your page or a little post-it note or something. We're going to be using those again and again and again and again. So don't be surprised when they come back in like 2 seconds. Okay, so your basic curves, let me just show you. I know I already showed you a graph of this. I just want to show you there's actually five important points really that we need. And there's not much that you need to do here. I just want you to follow along. Let's just take a quick look at the two curves, starting with sine. So let's deal with sine. We have when x is 0, y is 0. So that would be right here. Okay? Maybe I'll highlight it. When x is 0, y is 0. Just imagine that was the only point there. When pi is pi over 2, when x is pi over 2, y is 1. So we look for pi over 2, y is 1. That would be the second point. Put in pi. If you were to put in sine of pi, you could put this on your calculator, sine of pi. It would give a y value of 0. If you put sine of 3 pi over 2, you get negative 1. And if you had sine of 2 pi, you would get 0 again. You'll get used to these numbers over time. It's basically just versions of pi and half of pi. You'll see that that's enough to draw this curve. I'll delete this in a second, but look, I could draw the curve in between these 5 points. I could draw a sine curve well enough if I just had 5 points. So for the sine curve, these are important points. And something we'll notice more later, I won't write it down now, but it's the 0 value, the maximum, the 0 value again, the minimum, and the 0. That's all we need. I'm going to do the same thing for cosine. If you're not following, don't worry too much. I'm just trying to introduce some basics. For the cosine function, same thing. If I put cosine of 0 in my calculator, you would get 1. So for the x value of 0, there's a y value of 1. If you put cosine of pi over 2 in your calculator, you'll get 0. So at the point pi over 2, y is 0. And if we do this again, cosine of pi gives negative 1. Cosine of 3 pi over 2 gives a 0. Cosine of 2 pi gives a 1. We would have all the points we need, and actually, if you didn't have anything else, you could draw in between those points, and you would have a pretty decent cosine curve. Okay, so that's the basics. These are the important 5 points that we need. The maximums, minimums, and 0 values. I really wish that there was more focus on the unit circle in these courses, because the unit circle helps you understand this very, very easily. But I'm not going to cover that because I'd have to do a whole lesson on unit circle, which we don't have time for. One thing I will mention is that I'd like you to notice the y-intercepts. So for the basic sine and cosine curves, what are the y-intercepts? Well, for the sine curve, you can see it's at 0, 0. for the cosine curve, you notice something a little different. It's at 0, 1. Okay? So you'll see that the cosine curves, the y-intercept is at 0, 1. The cosine curve is at 0, 0. And again, most of this is reference, but sometimes these things come up, so I just want to make sure they're all out of the way. And I know I'm talking a lot. I get that. We're almost to the point where you can start doing some of your own thinking. I'm just setting up the topic. Okie dokie. So just a couple more little things, and we'll get right into the examples then. The only difference between sine and cosine is there's a horizontal shift of pi over 2. So you'll notice it says sine of x is the same thing as cosine of x with this pi over 2 value stuck onto it. Or you can see that the opposite is true. You can take the sine and add a pi over 2 and it'll be the same thing. That'll come up later if we need it. Don't worry too much about that now. But I do want to mention this. This is the last thing I'll note on this page. For the basic sine and cosine curves, the amplitude is 1. Well, that's pretty clear. Look at this. This distance here, that's an amplitude of 1 for both curves. They both go up to 1. The period is 2 pi. So from start to finish, 2 of the peaks, the distance between them is 2 pi. And the displacement is 0. So there's no phase shift for the standard function. Okay. Finally, these are the formulas we're working with. Okay. Now that I've put you to sleep, let's actually do some work. Let's do it very gently. The math side of this is actually easier. Hopefully you've been paying attention, but if not, you know, you can wake up now and let's get to some actual math. So the effect of the value of A, that's what this section is about. Really all we're talking about is there's a vertical stretch. So the value of A is this guy. Let's look at our formula, this formula here, and let's just say what's A, B, and C, and let's answer the questions, okay? What's A? Well, I want A, I want B, and I want C. This question's actually only about A, really, so it's going to be pretty simple. What's A here? Someone tell me what it is? 3. Good. Very, very simple, like I said it was going to be. A is 3. We just steal it from the formula. What's B? It's kind of hiding. You know, B is supposed to be right in front of the x. I don't see much of anything in front of that x. Nope, it's not 2 pi. If it was 2 pi, we would see it. Be careful with that. It's directly from this formula.
It's not 1?
It is 1. It is 1. Sorry, I had a couple of the answers were 2 pi. I didn't see your 1 in the middle there. It's 1. Yeah. The formula we're looking at, we're comparing it to this. So we can see A is 3 if we match it up. There's nothing in front of the x, which means it actually has to be a 1. It can't be 0 because if it was 0, it would delete the whole term. So B is 1. And then C, what's C? Well, I don't see anything after the x. So in that case, that is 0. Yeah, that's definitely 0. It's not 1 because we would see a 1. So that much is okay. All right, so we have our basics. Now we just do a little bit of math, and we have our amplitude, period, and displacement right away. And I put our formulas here, if we need them. They're on the side. I probably should have moved them over a bit, but it's okay. Actually, I still could, I guess. Yeah, whatever. So 2 pi over B. Amplitude is the absolute value of A. So in this case, just 3. We're done. Period is 2 pi over B. B is 1. So it's 2 pi. So Al Sadegh and I think Aisha said 2 pi for B. I think maybe you were thinking about period. Maybe. Amplitude is 3. Period here is 2 pi, which we can see. Maybe you were looking at this. You're like, hey, isn't B period? It's not. Period is period. B just gives us period. Okay, displacement, the formula is negative C over B. We have B and C. It's negative 0 over 1, which means 0. There is no displacement. It hasn't been shifted left or right. So that's it. That's how we do these questions. If it's asking for those three things, amplitude, period, and displacement, which it's always going to ask for, it's just really those three things. We find A, B, and C, and then we use the formulas. Okay? Pretty straightforward in my opinion. Let's look at our graph now. Let's actually look at the graph and see if our answers match it. Because really, let me just make it clear here. This and this could all be done without the graph. So all that yellow stuff, we could do that without ever having seen the graph. But it's a good idea to look at the graph now and see if it makes sense. So is the amplitude 3? Well, 3 is here. That means it should go from this line up to that. This should be 3. So yeah, amplitude is definitely 3. So we know that that's correct. What about period? Is period 2 pi? Well, I already talked about that. Period is definitely 2 pi. The distance between 2 points of the same type. Period is definitely 2 pi. And displacement. Let's see, displacement. Well, okay, the y-intercept hasn't moved. So if the y-intercept hasn't moved, you know, sine functions always start at 0, 0. The y-intercept is still at 0, 0. We're okay. So our answers match our graph. You could also do the same thing on Desmos. You could type it into Desmos and see what it is. Right? So that's that. That's basically all there is to it. This is all about A, and so it's just talking about vertical stretch. Nothing else changed. Let's take a look at the next one. Again, Tom did all these, but I want to do them with you because then I feel confident that you all understand exactly what's happening. Plus, it's nice to have someone live talk you through something. It's not quite the same watching a video that you can't interact with, so I get that. A, B, and C. So what's A? Let's do it quick. A is 1/2, 4.5. You can give either one. B is what? Well, there's nothing in front of the x, so it must be a 1, not a 0. What's C? Well, there's nothing after the x, which in this case, it's just nothing, so it's again 0. And I'll highlight these one more time. A is the number in front of everything. B is the number in front of the x, which in this case is 1. You could even add that in if you wanted to. You could write your own little 1. And then there's nothing after that. So really, we have no C. Now it's just a formula game. Amplitude, copy A directly. Just make sure you give it positive. Amplitude is always positive. Period. You know, the formula is 2 pi over B, and we have B. 2 pi over 1, 2 pi. So the formula, the period didn't change, which is fine. That makes sense because there's nothing next to the x to change it. Displacement negative C over B, that's negative 0 over B. We could write this directly. It's going to be 0. But just in case, you know, 0 divided by anything is still 0. So now we're done. Okay, story is complete. We can go back and look at our graph and see if it's true. So we can see if our answers actually make sense. Well, this is a 1/2 or 0.5. So yeah, that's our amplitude. Our amplitude is definitely a 1/2. Our period, is our period still 2 pi? Well, let me look at the first value. Let me go through the whole curve, make a full cycle up and down. See that it ends here. That's definitely 2 pi. Period is definitely 2 pi, so that's correct. The displacement has the y-intercept moved from 0, 0? No, it hasn't. So the displacement's 0, and we're okay. All right, so you don't need to do this check every time if you trust your work, but as soon as something goes wrong, it's a good idea to have at least one way to check your answer. And this is the easiest way, is to graph it. If you don't have the graph in front of you, you could use Desmos and make sure it matches that way. If you haven't used Desmos by this point, I really recommend it. There is really no better graphing calculator out there for this kind of stuff, even for higher level stuff. So, use whatever resources are available. Legal resources, anyway. All right, let's keep going. What's the effect of B? Well, we already talked about this. I already told you what the effect of B was. I said the B controls the period of the curve, so it affects the period. The bigger the B value, the more squished it is, which means it has a smaller period. If it's a really small B value, it's the same as pulling it bigger, and it has a wider curve, which means it has a bigger period. So it'll say if the number B is bigger than 1, the period will decrease. If the number B is smaller than 1, the period will increase. So big B, small period. Small b, big period. Just different ways of saying the same thing. So let's see what happens. Let's do our same game again, okay? Let me make this a little smaller because I don't want to take up too much space. Let's do our game. A, B, C. What's A? A is 1. B is 2. All right, so this is the first time it's been anything besides 1. And C is still 0. Okay? Amplitude in this case, 1. Period, 2 pi over B. So that means 2 pi over 2. Ooh, fancy. Cancel those 2's. You got a pi. And displacement, still 0. Let me just write 0 directly. There's nothing special about that, really. So the amplitude is 1. Does that match our graph? Yep. The amplitude's 1, so I can check that right away. The period. The displacement, I can see clearly that it hasn't moved, so I'll say that that's correct. The period. Is the period for this graph pi? Well, if we look in on this, is the period pi? We'll take any point on the graph and then look for the exact same point somewhere else on the graph. So for example, I'll just pick the easiest point, the y-intercept. Follow a full cycle, go up and go down. This is the end of that cycle. We can see that for sure the period is pi. You can see this value pi there. From start to finish, the amount of time it took, or the distance in the x values, was definitely pi. So it's been squished, it's been compressed, which is exactly what we thought was going to happen, or at least what I thought was going to happen, because we had a big B. Big B, small period. Okay, so the numbers lead us to this. The check is optional, but it's important to understand if you want to be able to check your work. All right? I'd like you to try B. B is cosine, but very little changes. Take 2 minutes and give me the answer for B, and we'll compare our values. So at 10:35, I'll come back. 10:35. So Ayesha was the only one who responded so far. I'd like a few of you to try it. I can see that your B is not correct for two reasons. For one thing, the B should probably have a pi in it. The other thing I would mention, B should definitely have a pi in it because the period will be a fraction of pi. But your fraction is wrong. So I'll talk about why. So keep working on this. I'm going to write out what A, B, and C are. A here is 1. Oh, sorry, your A, B, and C are correct. Sorry. I thought you were giving amplitude, period, displacement. Yes, of course, your A, B, and C are correct. Sorry about that. Full marks, Ayesha. 10 points to Gryffindor. And then 0. So we have A, B, and C. Amplitude is 1. That one's easy. We just steal the A value. Make sure it's positive. Period. 2 pi over B. Well, B is a half. So this is 4 pi, but I'd like to discuss why. Some of you are kind of terrible at fractions. And that's not, I'm not trying to insult you, just being realistic. Some of you are not good at fractions. So let me show you, actually, sorry about making so much noise here. I want to show you how I do that. Let me just make an aside. Some of you might want a way to do this without a calculator. I'll show you the calculator way after. 2 pi over a half. So we'll see this half here. The easiest way to do this is to consider what division means. So division, if you go back to the very first lessons you had on division versus multiplication, division is multiplication. It's division, it's multiplication by the reciprocal. So the fastest way to do fractions like this is to take what's on bottom, take the denominator and flip it. It's the same as multiplication or multiplied by the reciprocal, 2 over 1, or 2. So 2 pi divided by a half is the same as 2 pi times 2, which then is very easy. 2 pi times 2 is 4 pi. All right? That's the fastest way to do that, in my opinion, if you're not confident. Of course, this is 2 over 1. 1 over 2 becomes 2 over 1, but it's just 2. All right, the other way is to use your calculator. So just make sure you're confident with your fraction buttons. So I would set up the fraction first, put in 2 pi. Assuming you have a Casio. If you don't have a Casio, there's not a whole lot I can do for you right now. You'll have to figure it out another way. Sorry about that. Divided by 1 over 2. And it gives pi. Wait a second. What did I put in wrong? See, don't trust the calculator to do everything for you. Divided by 1 over 2. 4 pi. So I think I had a little brackety thing going wrong that time. 4 pi. There's another way to do this, which is if you don't want to include pi in there, because the pi is not doing anything. It's just hanging out. So we can go back and we can do the exact same thing as we did before, but just remove the pi. You don't need pi there. Just make sure you add it back into your final answer. So this gives us 4 pi. Just add pi to your final answer, included in your final answer. The other way, some of you don't have calculators that can set up fractions as easily. So just read off what we have. I have 2 pi over a half. So just use brackets, okay? I'll put in 2 pi, or just 2, divided by, and then if it's on bottom and you want to divide by the whole half, use brackets. So like this. So it's 2 divided by 1 over 2. That also gives 4, which you'd add pi to at the end. Now, some of you might be wondering, sir, just divide by a half. Just say 2 divided by half. 2 divided by 0.5. Of course, that would work. The reason I'm going through the steps is that in many cases, it's not a half. It's a more complicated fraction. And so it's easier to know the general rule than it is just to change it to a half. But it's up to you, okay? I think that's enough on that for now. So that's our 4 pi. Displacement, anyone get it? Are you all asleep? You with me? What's displacement? Negative c over b, that's our formula. Yep. I'll just go through the motions just to show you that it's definitely 0, but for the same reasons, 0. Does that match our graph? Let's see, it should be amplitude of 1. That's an amplitude of 1. Good. Period should be 4 pi. So from start to finish, or from point peak to peak, we should have period. And we do. Perfect. By the way, we could have, we could choose any point on this graph and see what the period is. For example, what if I looked at this point? Let me give it a different color. Maybe I wanted to look at this point. Well, I could go through a full cycle, go down, come up, come back to where I see the same thing again. The distance from these two is 4 pi. It's 5 pi minus pi, which is 4 pi. So it is the same. You can take any 2 points on the curve and get the period, as long as the 2 points are in the same point in the cycle. All right, so I've checked my answer. I don't need to keep all that there. And you don't even need to check your answer, but if you're trying to get full marks on this stuff, good idea to be able to check it, okay? One thing I will mention is that what happened when the b was a half? Being small, it should increase the period. And we see that it is indeed increased. It used to be 2 pi, it increased. So we're getting our answers match what we expect it to be. Okay, and there's no displacement. Let me make a note of that. You can tell by the graph that there's no displacement because cosine x has a y-intercept. If you remember from a few pages ago, the y-intercept for cosine is 0, 1, which it hasn't moved. So the cosine starts on a hill and then starts going down. Sine starts in the center and starts going up, So cosine, it hasn't been shifted because this is where it started in the first place. If you want me to show you what I mean, this is our basic cosine function. Our y-intercept hasn't moved. Okay, just trying to get you an idea. There's a lot of different ideas going on here. None of them are actually, I would call, difficult. But if this is kind of new to some of you, that's why I'm repeating the same things. Those of you who aren't so confident with this, you might not even notice that I'm repeating ideas. I'm doing it for you to try and get it in your head. Okay? So, what do you think's next? We've done A. We've done B. Maybe we'll focus on C. So let's focus on C. What is the effect of C? Well, I already talked about this. The C affects the phase angle of the curve. There are many words for phase angle. If I asked for displacement, or I could even call it phase shift, or I could call it horizontal shift, or I could call it horizontal translation. They all mean the same thing. They mean literally the same thing. They are all the same thing. They're just asking for how has the graph moved left or right. We already talked about that. One very important point for later, if C is positive, the graph will be moved left. If C is negative, the graph will be moved right. And we've done that. We did that already. We did that in the last unit. If we affect the x value, plus or minus something, we always shift it. Let's get right to it. Let's do the example. Tom did this as well, but I want to do it from scratch. What's A? 1. What's B? 2. What's C? C is not 0 anymore. C is going to be pi over 4. How do I know that? I know it because there's this in front of the A. I can also see that there's a value in front of X, that's our B. And our C value is whatever's being added or subtracted from it. And it's in the brackets. You'll notice it's in the brackets, it's not outside the brackets. That's a different thing. Once we have A, B, and C, the rest is, in my opinion, just math. Before I do this, I want you to try and, maybe I could give you a quick little multiple choice or a bonus question. How does B affect things? Will this compress the graph or stretch the graph if B is 2? What does B do? Does it stretch it or does it compress it? Does it make the period smaller or bigger? Well, if B is bigger than 1, it will compress the graph. It'll squish it or compress it. Yeah, exactly. So yeah is exactly right. Compress it when it's higher. If it's bigger than 1, it will make it smaller. It'll compress it. So we've got a smaller period. So smaller. Both of you are right. Good job. What will C do? C is positive, so it'd actually be shifted left because that C is positive. Got a positive here. Okay. So you don't need to write out, you don't need to write all that when I ask you these questions, but it is important to at least have some idea what we're talking about. Okay, let's do our job here. We have A is 1. That one's easy. Just steal it. Period is 2 over B, 2 pi over B, 2 pi over 2. Hey, we saw that one before. So period must be pi. Is period pi? Let's see. From here to here is pi. Yep. So the period is pi. We're okay. C. Let's see. Non, what are you saying? 0, 0 plus dot. 0, 0 plus dot. Do you have a cat? Did the cat jump on your computer while you're sleeping? I'm just kidding. I'm sure you're not sleeping. Well, I'm assuming you're not sleeping. Displacement, negative C over B. That's pi over 4 over 1 over 2. Okay, let's see who can handle this one. Ooh, negative pi over 4. Negative 1 over 8 pi. In other words, I'm just going to put the pi on top just to simplify it a little bit. But yeah, negative 1 over 8 pi. I agree with you. I think that's a perfectly reasonable answer. I'll just do the work over here. We had negative pi over 4 divided by 1 over 2, which is the same as negative pi over 4 multiplied by 2 over 1, right? I like to do this by hand because it's something not too difficult. Multiply the tops, multiply the bottom. Wait a second. What did I? Oh, B is 2. What am I even doing? Silly me. Silly me, silly me. This is divided by 2. We did this before, but I don't mind showing it again. Okay. So that's why we have it. Sorry about that. I had a little issue with my old brain here. We all had a break, you know. Hopefully you didn't do too much work over the holiday. I didn't either. Spoiler alert. So, you know, we all take a little bit of time to get back into our groove. Okay, pi over 8. So, long story short, it has not been stretched up and down. It has been compressed. So the period is smaller, which is what we expected. And then it's been shifted just a little tiny bit over. So it's been shifted over by pi over 8. And if you look very carefully here, the distance from here to here That's negative pi over 8. Let me make it more clear. It's been shifted from there to there. So we can see we're okay. All of our answers are correct. Are we okay with that? Have I lost some of you? I can't get a great feel of how we're doing. I know Ayesha is doing okay. She's answering me. Is everyone still alive out there? You doing fine? Am I going too slow, too fast? Okay. This is what I want you to do. I would like you to try 1, 2, and 3. 3 was done by Tom, but I'll still do it again. And then as a challenge, a slight challenge, not too bad, I'd like you to try 4, okay? I'm gonna give you 5 minutes. I'll come back at 10:55. You know, you can type out your answers or just write them yourself on your notebook or whatever, but I'd like you to try them. If you can do these, then you can pretty much do any of the questions that I want you to do. The rest is just gonna be practice, okay? So I'll come back to you at 10:55. Do as many as you can. All right, so I gave another extra minute or so just to see if we could finish. Aisha and Al-Sadeg, Guma? I don't know. I gave another minute just so that people such as Abdulaziz could finish, but it looks like maybe you didn't do one. So, oh, I'll just put up the answers just because I don't need to do the whole thing. I'm not going to do the calculations. I'll just do them quickly. Here, for example, A is 1, B is 1, C is negative pi over 6. If you know those, then you know you can get the amplitude of 1, period can be 2 pi, displacement pi over 6. So we already had those three answers given. I'll sketch them out just so you can have them. For the third one, or sorry, second one, we have A is a half, B is 1 again, C is pi over 6. And then if you go through your same formulas, we have A is just A copied, period is related to B, but not B, but it's 1, so it's just the same as it is originally. Displacement is going to be negative pi over 6. And that doesn't change much because it's negative C over B. So you got these guys and this guy. Just our regular three pieces. This last one, A is a half, B is now a fraction, so we have that to deal with. C is also a fraction, so we have that to deal with. So let's see, we have amplitude is going to be a half, that one's easy. Period is going to be, let's see, I'll do this one out for you, 2 pi over a half, which we've done this, actually this is the third time I think we did that one. And then displacement, I'm writing out different ways, A and P, period, P, displacement, DISP, D, just so that you know that they all mean the same thing. And then displacement is going to be negative C over B, which in this case is negative pi over 4 divided by 1 over 2. And for the same way, for the same reasons that I went through before, you should hopefully see that this is pi over 2. Does anyone see if I missed anything here? There's one tiny little thing that I missed. And that's the formula itself has a negative in it for C. So just be careful. That's a really easy mistake to miss. Miss that there's a negative in front of all this. So that's why it pops out a positive when we're done. Okay, those are our three answers. I'm not going to do the workings because there's no need. I've already done the workings a whole bunch of times. But make sure you know how to do the algebra. Let me just take a quick look at it. So did anyone try 4? 4 is a slightly different way of doing it. We actually have to do things backwards. So let me show you what I mean. If you didn't try 4, well, just make sure you watch this, because this is another type of question you're going to be expected to know how to do. So it says, give the equation of the graph. So we need to give an equation. That'll be, that'll be in this form. Sine bx plus c. Or, let's not forget about our cosine. It could also be cosine. That's equally fine. I actually prefer cosine. I think it's a nicer function. But same thing. So one of these, and really we're looking for its three pieces. We need A in either one. We also need B, and we need C. The nice thing about these questions, though, is like, unlike Unit 3, where we had to find the equations and it was a lot of work, these are not a lot of work. These are actually pretty simple. So what we're given, it says amplitude of 2, period of pi, no phase shift, and then it's reflected through the x-axis. So I'll deal with that last piece of information later. So look at this. A is given. It's 2. What that means is that A must also be 2, little a. So that one's pretty simple. That one's done. Where it gets interesting or tricky is when we get to things like period. So period is given directly. It's given as pi. What's the formula for period? Well, it's 2 pi over something. 2 pi over b. If period is 2 pi over b and period is pi here, then this must be true. 2 pi over b must be pi. If you solve that, you'll end up seeing that b is 2 pi over pi or 2. There we go. All right, so we've got A and we've got B. If you don't know how to rearrange this, be careful, just do some cross multiplication. Make sure you know how to do it. You're multiplying both sides by B and then dividing both sides by the pi. Finally, displacements. Displacement in this case, given in the question, is 0. Well, we can see that C will directly be that, but let's just be clear. We know that displacement is negative C over B, and we know it's equal to 0. If that's true, then C has to be 0. So we have our 3 pieces, okay? We have A, we have B, we have C. Let me just color code it. Hopefully it doesn't make it more complicated. I'm just going to build equations with those 3 pieces. It should be simple. So y is A sine 2x plus c, well, plus 0. So done. If you want to know where each piece came from, this is our A, this is our B, and it's done. The problem is I haven't finished. There's a little bit of a trick here, which is what makes this question harder than it should be, or harder than it normally would be. This is coming back to haunt us. Functions reflected through the x-axis. What does it mean when something's reflected through the x-axis? When we reflect something in the x-axis, what effect does that have? What does it change? Negative, yeah. What's negative? Is the x negative or is the y negative? Y. Yeah. The y will transform into negative y. But really what that means is that it's just going to add a negative in here. So the y becomes negative, we just bring it to the other side, it makes the whole thing negative. So that's the trick. I probably wouldn't give you a question on reflections in the trig section, but it's not up to me to add all the questions. My teaching team has to discuss it. So I wanted to make sure I covered that. If you have a reflection of the x-axis, just put it at negative on the front and you're fine. Or let me just go ahead and fill in the same thing for cosine here. Very simple. You can use whichever one you want. It'll be negative 2 cosine 2x, and you get the same thing. So for some reason, whoever made this book chose not to give a whole lot of space for the questions. Maybe they're just trying to get a lot done in a little amount of time, but it should have had a bit more space. There's not quite enough space for these questions. Okay, so we're basically done. I just want to do maybe three more questions, and we'll be done for the day. Okay, because the rest is just practice. Before I do that, are there any questions on this question 4 here? Going once, going twice. So practice 2. So all of these questions here where it says find the amplitude, period, displacement, that's what we've been doing all day. So these can just be homework. You know, all of these, I don't need to write all that actually. Practice 1, you can just do for homework. You know, before the assignment or something, before Tuesday, just go ahead and give those a shot. They can be review questions. They're all done the same way, as you've seen. There's no real tricks. For 2 is a question more like what we just did. And I'm going to just do, I'm going to do A for you, and you can do B and C on your own time as for the same reason, just for practice. But what it's trying to ask us, or what it is asking us, is to write the sinusoidal function. Sinusoidal, by the way, just means sinusoidal, sine x, or cosine x, sinusoidal. That's where the name comes from. And it says in terms of sine x, so we actually don't need to worry about cos x too much. It gives us the 3 main pieces, amplitude, period, phase shift, also known as displacement. We just need to fill in the values like this. So if this is our general formula, let me make it a little bit less aggressive here. If that's our formula we need to use, we just need to find A, B, and C. And thankfully, that's very simple. So the amplitude, let me just move it up here. If the amplitude is 4, then the A is 4. So that's going to be very simple. I can actually put that in already. I know it's going to be sine, and then I'm going to put some other things in. There's going to be an x here. Let's see what we get for B. So the period, we just did this. If the period is 3 pi, and we know period is 2 pi over b, then we can use this. Again, the formulas state that period is 2 pi over b always. In this question, we were given that period is 3 pi. So 2 pi over b equals 3 pi, and we just solve it for b, okay? So if we rearrange that and solve for b, which you can just, look at this. This is the same as being over 1. You can just do some cross multiplication. You end up seeing that we have b equals 2 pi over 3 pi. Cancel, cancel. B equals 2 over 3. So in this case, we don't have a pi, because again, we're going backwards. B is usually a whole number. So I can fill that in, 2 over 3. I've built most of my equation. All I need to do now is find C. So because this is really one of the last things we're going to do, I'd like you to tell me what that is. I'll give you the basics. And I'd like you to solve for C. I'll give you one more piece of the pie, one more piece of the puzzle. How do I get that? Some of you will look at that and just sweat and have no idea what to do. Others won't have so much trouble with it. How am I going to get that C? Anyone have any ideas for what this C will be? Yeah, that's a tricky one. So yeah, you can cross it over. The way that I like to deal with fractions most times is whatever the denominator is, whatever the bottom number is, especially, if there's a bottom number that's causing you trouble is really my point. So for example, 2 over 3 here is clearly causing me some trouble because I don't want it to be there. I'm going to multiply on both sides by that. Yeah, Aisha, you got it. Good job. I'm going to multiply on both sides by what's causing me trouble, which is this 2 over 3. I'm going to keep the C. I'm going to multiply both sides by the 2 over 3. It'll cancel it. on the left side, and I'll put it on the right side. So it looks like this. And I think once you see it like that, you can simplify easily. Just multiply the top, multiply the bottom together. So C is then 2 pi on top, 9 on bottom, and there was a negative, so I'm just going to move the negative over. Okay, that's our answer. Negative 2 pi over 9. So these are a little bit trickier. It's a little harder to go backwards, honestly, than it is to go forwards. I wouldn't say it's much more difficult. It's just a little trickier. So make sure you understand how to do this algebra stuff, or you're not going to be able to solve these questions. And once again, there's not nearly enough space on the page for these to be done. So hopefully you have your own notebook. So great job, Ayesha. You're the only one who replied to that with the final answer. So that's excellent. That question's done. If you want more practice on that, please try C and B and C. So I'll finish the rest up pretty quick because I don't want to take too much of your time. Normally I like to finish 10 after the hour. Let me quickly do C and 3 and 4, and we'll be done. So first things first, it says express this function in terms of cosine. And there's a little bit of a trick. The trick is something that I mentioned earlier. Cosine is sine x, but it just has a phase shift of pi over 2, negative pi over 2. So let me show you what it looks like. It's very straightforward. First of all, this is in a weird form. If it has a 4 on bottom like this, just divide both terms by 4, and it'll simplify really nicely. So what I mean is keep everything the same. Take 2x divided by 4. That's x over 2. 2x over 4 would simplify to 1 over 2. So x over 2. Pi over 4 stays pi over 4. And the reason I do that is now I can work with it. So just follow me. You wouldn't know how to do this necessarily on your own. Just believe me, this is how you approach it. What you'll do, because sine and cosine are basically the same function with a phase shift, we can take the sine, change it to a cosine, keep everything else the same. Okay, everything else is the same so far. And we just add a phase shift. And that'll compensate. That'll make sure that it's still the same exact function. So I'll just phase shift it here. All right, and that's all you do. If I ever ask this question, that is all you need to do to transform from sine to cosine. If you put this in your calculator, pi over 4, pi over 2, you'll get the answer to be 3 pi over 4. That's our final answer. Okay, and if you were to graph this and this on Desmos, they would both come out. They would be the exact same function. I'm not going to do that now because I don't want to waste the time. Okay, so long story short, if you're given sine and you want cosine, take your sine function, change it to a cosine, and add that extra pi at the end. And this wasn't some sort of magic. I'm not giving you anything too crazy here. If you have negative, I hate this touchpad, negative pi over 4, whoa, negative pi over 4. Again, some of you have a lot of trouble with this, which is why I want to show it. Negative pi over 4 minus pi over 2. These Casios will just do that for you. So actually, I made a little tiny mistake here. It says negative 3 over 4 pi. So this shouldn't be an x. This should be pi. Sorry about that. Okay. So I'm going to just finish the rest, okay, real quick. I don't want to take any more of your time. For the last question, for the function y equals 2 cosine x over 2 minus pi over 5, what is the phase angle? Phase angle is another way of saying what is the displacement. This question is really easy. if you know what you're doing, if you know the formula. So the displacement is negative c over b. We know that because that's the formula. We were given c and b. So this is the same as saying negative c over b. b is 1 over 2. This is the same thing as saying pi over 5 times 2 over 1. And so this is 2 pi over 5. I'm not going to go back through that algebra, but you can try that on your own time when you want to look at it a little more closely. But that's how you do these things. We've covered everything we could really need to know about this topic. Tomorrow, we're doing 2 other topics. We're going to know how to graph sine and cosine nicely, and we're going to make the equation from the graph. Without being given a, b, and c, we're just given the graph. So all related to what we did today, but just from a different point of view. So before I let you go, I just want to reiterate something. The assignment is not tomorrow, the assignment is Tuesday. I know I said it for tomorrow, but I moved it 1 day ahead. I think most of you, that's better. It will cover the whole unit, but the whole unit is only from page 15, okay? So page 15 to 35 is what your assignment will cover. So today's class and tomorrow's class. Other than that, that's basically it. It's nice to be back. I hope you had a restful break, and I hope I didn't, break your spirits by giving you the math class at the early in the day. I'll stop the recording here. Bye-bye, everybody.